So for this second session, let's welcome Nikolas Pontikos to the stage, professor at UCL and co-founder of Eye2Gene.
Thank you. Cool. Okay. I'd like to welcome as well William Wolf, who's a postdoc working with me, and he will be sharing the talks. I'll be covering the first part, and he'll be talking on the second part. William, maybe you want to stand here so you can jump in. Great. Okay. So thanks a lot for inviting us. Very excited to be part of this really cool conference. So we are working on Eye2Gene. I'll explain a bit what it's all about. So we work with genetic eye diseases, and these are images here you can see of retinas of people who are affected by these genetic eye diseases. What's important to know is that they are a leading cause of blindness in young people all around the world, and there's a lot of different types of the diseases. What you've got, these images below, you have the genes which are affected in each of these people. So there's over 300 genes that can be affected in these individuals, and they cause irreversible sight loss, and it varies depending on the gene. And it's really important to identify the gene that is causing this person's disease, so that's called a genetic diagnosis. Why is it important? Because gene therapy is coming online, and we have a lot of these gene therapies now that are being developed. And what's common to all of them, though, is that you need to treat the patients early, so you need to identify the patients really early. However, genetic testing is not available all over the world yet. We only have, we're looking at the tip of the iceberg here in the countries where we can do genetic testing. There's a huge amount of patients all around the world that are not having access to genetic testing. So how have we solved this? We are using AI from retinal images to try and identify what is the disease that is affecting these patients. So it's a simple sort of convolutional neural network approach from retinal images, identify the gene. And we've got a accuracy of detection of 93% to see whether it's a genetic eye disease, and then we can identify the specific type of gene to an accuracy of 86%. We've got a nice local data set that we've been using to do this, but we really need to go global, and we want to be able to run this and train on data from all over the world. We've got a large network of different sites all over the world that we would like to work with. However, as you probably know, information governance is a big barrier to being able to centralize data, and rightfully so, because privacy is a big concern in healthcare. So we really must turn to a federated approach. So I'm going to let maybe William now talk about what we've been doing with Flower to address this.
Thank you. Hello, everyone. Yes, so we'd like to talk about a project we've been doing, which was part of the UCL CDI, Centre for Digital Innovation Accelerator Program. And this is about taking some of the research that's been going on at UCL and sort of speeding up and maybe even helping to find sort of commercialization. So as part of this, we received help from AWS and as well some support from Flower. And this was really for us sort of a pilot project about sort of trying to sort of kickstart our federated learning capabilities. And what this really forced us to think about is it's one thing to be able to talk about all the technical aspects of federated learning, but it's another thing to be able to get a system actually running in a hospital, in sort of like a research setting, to be able to do federated learning for that. And there's a number of particular challenges. Number one is many of our collaborators who we'd like to work with and get federated learning set up with are clinicians, and clinicians do not tend to have extensive sort of computer science expertise. They're often very capable, but you can't just ask them to go and set up complicated environments and so on. And another issue is, even if they can, IT systems in hospitals. Obviously, we've been hearing a lot in the UK about digital attacks. Obviously, there's very real concerns about data privacy and security. So IT are very keen not to let stuff run anything. So while it is in theory possible, there's a lot of bureaucracy involved, a lot of overhead, and also just thinking about, even just from a practical perspective, every hospital system is different. And finally, as well, sort of building on that idea is you need compute. And getting compute into a hospital environment is difficult. And even if you can, do you want to be spending potentially thousands of pounds for every single site you want to collaborate with? Or getting a GPT machine running. So going to this, we sort of had a sort of list of requirements we really wanted to think about. We wanted to make whatever system we came up with as simple to set up as possible, so potentially it can be sort of like a one-click solution. We wanted to make something that was minimally reliant on existing IT resources that could ideally be operated sort of parallel to the hospital IT system. And I think sort of finally that last point sort of really drove a lot of our solution, is thinking about how can we actually get compute available to the sort of end nodes, so the clients. So what we could have really turned to for this was thinking about can we leverage cloud infrastructure. And now I know somebody might be thinking that this sort of all seems to defeat the point of having the sort of privacy aspect. What we can find we can do in many instances is enable hospitals to have secure cloud environments which they control and move data there. And that we felt was really the key to sort of enable us to then standardize platforms for our partner sites. Now we're still sort of thinking about one cases where that might not be possible. It still may be possible to do this based on local data, but that's the thing. But one thing sort of thinking about then even as well, as I was saying, that compute problem is still a very big issue. And if we're using cloud resources, we don't want to be running GPU servers for every single of our external sites, because it's just going to get very, very expensive. So what we kind of did is we decided for our sort of client node, we're taking a very standard sort of Flower client node here, but we're basically offloading the compute elements and also to some extent the data management to a separate process. And for that, what we're using is Nextflow. This is something that's been used a lot in sort of genetics pipelines, and we found that we can get it set up very nicely to run deep learning workloads. And that's nice because you can then basically, you can either run that locally, or you can ship that off to something like AWS Batch, and that can then get run by on-demand compute instance. So the way this works is basically we take our Flower client, and all that's doing is basically taking the incoming weights from the incoming parameters, saving them, working out how to, building up a call to the Nextflow script, and then the Nextflow script will go off, run, do the job. It's got access to the data. That might be on an S3 bucket or so on. And then that will come back and then save another set of train weights, which the client can then read off its local disk and then send back up to the Superlink and so on, sort of to do the standard sort of federated learning. And so, this is nice in many ways. So the client node, pretty much all it needs to be able to do is take some incoming data, save it to disk, and then read it back and send it off. Minimal overhead, minimal requirements. And sort of this encapsulation of different resources is something we think could be sort of, is worth exploring. So we sort of, maybe I'll go back a couple of slides, we sort of did a sort of demo of this. We've taken our, we sort of did a simulation of how this would work. We've built sort of independent AWS, I believe they're VPCs for the individual partner sites we were working with, used some temporary data, and basically use that to do a beta federated approach. So we don't do anything special. We haven't been doing anything special at the moment. That's something we really want to sort of explore, and hopefully something we'll learn a lot more about here. So we sort of see that just demonstrating that if we're only reliant on local data, then we're very restricted. But as more data we can get, especially in something like this where data is very scarce, that can really sort of accelerate our really help to improve our model. So just to summarize, we're going to continue working on this. Hopefully the idea is that this will then sort of become a key part of our process rather than just training on the data we have already. We're going to try and move more to a sort of federated first approach. We're very interested to learn more about what we can do to improve our process, particularly as we have stuff like big data imbalances. We also want to understand more about security, not just from a sort of technical perspective, but also like just how can we stop ourselves from being able to run arbitrary code on individual clients and so on, and finally sort of start properly deploying this. So just want to say a very quick thank you. So this was very much a collaborative project. So Alan and Ismail in particular worked quite a lot on this. But thank you as well very much to the CDI team at UCL and also our support at Flower really helped to get this off the ground.
Thank you very much, William and Nikolas. Do we have any questions? I think, yeah, over there.
Thank you for the great case and also for the clinical relevance of your case. I have a question about the incentives for the data partners, for the hospitals to join your project. Do you mind to explain a little bit, what brings them to join, collaborate, and kind of the shared incentive or convincing factors to join you?
So there's several incentives. Firstly, obviously, patient care, so they're able to use this algorithm for their patients. They don't have a lot of expertise, a lot of these centers in these genetic eye diseases, so we are able to bring an expert system to them. Then there's an incentive, obviously, from a research perspective. They want to contribute to this on a research basis. And then I think from also a commercial point of view, their data is also used in training this algorithm, and they can, this is something we're discussing actually, is potentially how is this then reflected in any sort of commercial activity, for example, revenue share and so on. So that's an interesting one. But just being able to use it and be part of the project, because these are conditions which are very neglected, is really important to them to deliver better care for the patients. So I would say that would be the first incentive for a lot of them.
So I think we have an online question.
We've got a question from online. The question is to the Eye2Gene folks. They want to know just how much better could this get if you're successful? Do you want to get it?
Yeah, I think obviously. So at the moment, we're sort of seeing that based on the data we've got from Moorfields, is about 3,000 patients, maybe a little bit more. At the moment, with the stuff we've got from external sites is still quite low, but there are huge numbers of patients worldwide. I remember I was at ARVO a few years ago. Sorry, no, just last year actually. Sorry, yes, ARVO, the big American Eye Conference, and this was I had a clinician from China who was very interested, and I was just speaking to her, and I was asking her, how many patients have you got? And she was saying about 3,000-4,000, and that's from one hospital in China. So there's places in, there's patients in India. Now, obviously, they may not have the genetic, they may not effectively have the labels we need. But there's lots of stuff we can think about, and so we think this can get a lot better. But also as well, I think we're thinking about in terms of how we can actually, as well as improving our algorithm, actually get it into potentially into the hands of researchers without sort of one of the things we sort of think about. We're obviously very conscious of the importance of open source, but as well protecting our own IP in case we want to commercialize it and so on. So federated learning is, as well as coming a way of getting data for us training, it's also a way of us being able to run models on external data without having to either transmit any data or I know we were transmitting model weights, but it's a potentially much easier way of doing that than having run it independently.
Yeah, I think we're out of time. But yeah, just specifically, I think we can get an increase of maybe 10%. I think because we've got our data set is big, but there's huge data sets that we're not tapping into. So yeah.
Thanks a lot.